In Units 3 and 4, we will be looking at quadratics. So in this lesson, we're going to look at the properties of a quadratic, just to review what we learned in grade 10. So let's start out with the graph of a quadratic. So remember that a quadratic means that it has x to the power 2 in some form. So the y is equal to x squared. So what it produces is a shape that is called a parabola. So it's got this curved shape. All quadratics look like this. It is symmetrical, which means that we could fold it down the middle and the left side could be exactly the same as the right side. So let's look at some of the properties. One property is the vertex. So the vertex is the turning point of the parabola. So it might be as it goes down and turns up, or it might be as it's up and turns down. So thinking about the different shapes, a parabola that opens up is called concave up. And you can see that the arms are pointed up. And this graph would have a minimum value. So sometimes the vertex would be called the minimum because it's the lowest point. You could also have a parabola that turns down. So you can see the arms point downwards, and this is called concave down. And this vertex would also be considered a maximum point because it is the highest point. So the vertex could also be called minimum or maximum depending on which way it turns. The axis of symmetry goes through the vertex, and it's that line of symmetry that divides it in half. So this line that goes through the vertex is called the axis of symmetry. We have some intercepts. So remember, the word intercept means where the graph crosses or meets. So the y-intercept is here. It's where it crosses the y-axis. So this parabola has a y-intercept of x being 0, y being -3. That's that point. And then the x-intercept is where it crosses the x-axis. This parabola has 2. So it has one x-intercept at 3, 0, and it has one x-intercept at -1, 0. So you'll see with the y-intercept, x has a value of 0 because it's on the y-axis, and you'll see with the x-intercepts that y has a value of 0 because it's on the x-axis. So those are the main properties of a quadratic and the shape of the parabola. So if you go back to grade 9, you might remember that we looked at linear functions in grade 9, and the equation was y equals mx plus b generally. So you have 1x, 1y. So when we were deciding with a table of values whether the function was linear or nonlinear, we looked at those first differences. So the first differences are the values of y as x changes. So we're asking what happens to the y as x increases. So we subtract the y values. We subtract 4 minus the 1 before it, which is 9. So that has a difference of -5. And then we do it again with the next one. 1 minus 4 gives us a value of -3. We can complete the table. This is the graph of y equals x squared. So we can just take these values of x and square them to get y. So 0 squared, 1 squared, 2 squared, 3 squared, and then we can continue these first differences. So if I go from 1 to 0, 0 minus 1, I'm going down by 1. If I go from 0 to 1, that's 1 minus 0, which is 1. If I go from 1 to 4, that is 4 minus 1, so it's going up by 3. And if I go from 4 to 9, 9 minus 4, it's going up by 5. So you'll notice that the first differences is not a constant value. So if it's linear, from grade 9, we knew that the first differences were the same. And that told us that it was a straight line. In this case, they're clearly not the same. So we're going to do it again and find the second differences. So the second differences means we're just going to do it again. So we're looking at how do the y's change as x increases. So we do -3 minus a -5. So minus a negative is like adding. So that gives us a value of 2. Then we'll do -1 minus -3. So -1 plus 3 is 2. We'll do 1 minus -1. So 1 plus 1 is 2. Then we have 3 minus 1 is 2, and we have 5 minus 3 is 2. So we can see that the second differences are the same. They all increase by a value of 2. So if the second differences are the same, that tells us it is a power 2. So if it is quadratic, or power 2, the second differences are the same. So if the first differences are the same, it's linear. If the second differences are the same, it's quadratic. And the graph would just look like this. I could just plot these points and get my quadratic. So there is the basic graph of y equals x squared. Sometimes we call that the parent function because it is the starting function before we do anything to it, like stretch it or shift it. So the parent function is y equals x squared. You can write a quadratic equation in several different ways. We have what is called standard form. So standard form is ax squared plus bx plus c. We could have vertex form, which is a times x minus h squared plus k, where hk indicates the vertex. And you can write it in factored form, which will allow us to find the x-intercepts. So each equation has its useful, each form has its specific uses. So we might use one of the three depending on what the question is asking us to find. If it's asking us to find the vertex or the max or min, then we need to have it in vertex form. If it's asking us to find the x-intercepts, we might want to have it in factored form. So in this unit, we're going to be able to go back and forth between the different forms and change the equation according to what we are looking to find. So we might want to change from standard to vertex, or we might want to change from vertex to standard. Or we might want to change from standard to factored. So depending on the question, we'll be changing back and forth between the three forms. So let's have a look at this question. So here we could do a couple of different things. We could make a table of values, or we could use the information in the form that it's in. So this is in vertex form. So the vertex is here, hk. So the vertex would be 1 and 3. So remember, it's just the 1, not minus 1. It's just the 1 and the 3. So I could plot the vertex. 1, 3 is here. And then the -2 tells me that it's concave down. So it's going to open down. And the 2 tells me every time I go down 1, the y is going to change by 2. So if I go right 1, I'm going to go down 2. If I go left 1, I'm going to go down 2. And that's all I really need to sketch it. I know it's going to look something like that. So vertex form allows me to sketch it by locating the vertex and then deciding whether it's concave up or down and looking at the stretch. Oh, if it's in factored form, that gives me other pieces of information. So if it's in factored form, I could take each factor, set it equal to 0, solve for x, so I'll move the x to the other side, and these give me my x-intercepts. So I have one x-intercept at 3 and one at 5, -5. So I have one at 3, I have one at -5. So that gives me those. What else could I find? Well, I could find the middle, because I know it's symmetrical. So I could find the middle. The middle is like the average between the 2 points. So I could add 3 and -5 and then divide by 2. So I know the middle's at -1. So the middle is somewhere on here. There's the axis of symmetry. And I know that the vertex is on that axis of symmetry. So I could find the vertex by taking the middle point, x equals -1, and putting it into the equation to find the y that goes with it. So -1 minus 3 times -1 plus 5. So that's -4 times 4. So the y that goes with -1 is -16, which is down here somewhere. And then I could draw it from there. Right? So if you're just sketching it, I have enough information to find the x-intercepts, which means I can find the middle, which means I can also find the vertex.